5 translation process. After finishing transcription process and after talking about transcription process, which is the formation of mRNA from DNA by using DNA as a template, now we're going to talk about translation. Do you remember the central dogma of molecular biology? Central dogma of molecular biology states that the process of protein formation includes number 1, replication, then transcription, number 3, translation. Replication is the copying of DNA, which takes place in the nucleus. Transcription is the formation of RNA. It takes place in the nucleus also. What about translation? Translation is using mRNA messages to turn those messages into amino acid sequences, which takes place in the cytoplasm. This is translation process. It converts mRNA messages into polypeptide chain or protein. So first of all, let's know what is protein. The protein composed of long chain of amino acids. Amino acid linked to amino acid, amino acid, amino acid. So long sequence of amino acids connected together by peptide bonds. This is the protein. What makes one protein different than the other? The difference in the arrangement of amino acids. So here, for example, this amino acid is the first one, second one, third one. By rearranging or another arrangement and another way of connection of those amino acids, another protein will form. So the king here in the process of translation is mRNA. Where is it formed? It forms where? In the nucleus. Very good. After processing of mRNA, mRNA will leave the nucleus to go to the cytoplasm to start translation. Translation, what's the meaning of translation? To turn the codes on the mRNA into amino acids. Those codes are called codons. So codon is a sequence of how many nucleotides? How many nucleotides, how many letters are there in the secret word or in the password? There are 3 nucleotides. So a codon is like a password. This password composed of letters. How many letters? 3 letters, 3 nucleotides. So a codon is a sequence of 3 nucleotides. Each 3 nucleotides codes for amino acid, one amino acid. For example, how many codons are there on this mRNA? 1, 2, 3. This is one codon. This is one codon for methionine, AUG. Then CUU, another codon for leucine. So how many codons are there? We should count the number of nucleotides and divide the number of nucleotides by 3 to find out the number of amino acids that will be formed and to know the number of codons. AUG is called start codon. So any translation process starts at the start codon. It signals the start of translation. It signals the start of translation. How many amino acids are there in nature? Amino acids, 20 amino acids. So at least each one amino acid should have one codon. So at least we should have 20 codons. So there is one question. Can a codon contain only one? Can a codon contain only one nucleotide? Can a codon contain only one nucleotide? Of course not. Because if so, we will have how many codons? Only 4. But actually we have 20 amino acids. So a codon can never be only or can never form from only one nucleotide. Can a codon contain only 2 nucleotides? Of course not, because if so, we will have only 16 codons, which is impossible. That's why they found that there are codons and each codon composed of 3 nucleotides. What does it mean? It means that there are 64 codons. 64 codons. If there are, or if each codon contains 3 nucleotides, so we will have possibilities of 64 codons. But actually we have only 20 amino acids, not 64 amino acids. What does it mean? It means that one amino acid might have more than one codon. One amino acid might have more than one codon. Let's see. There is a table, this table for genetic codes, all the genetic codons. So the genetic code matches each codon to its amino acid. For example, UUU, for which amino acid? Phenylalanine. UUA for leucine. UCUG for leucine, and so on. There are 3 stop codons, like as I told you, start codon to signal the start of translation, stop codon to signal the end of translation. Stop. Now the protein is formed, no need for more translation. So once there is stop codon on the frame shift, the translation will stop. Once there is stop codon on the frame, the translation will stop. This is the frame. Look here, AUG is the start codon. There is AUG, so the translation will start. What if there is here stop codon? The translation will stop. Let's go back to this table. As I told you, each codon composed of 3 nucleotides, and one amino acid might have more than one codon. For example, phenylalanine. 1, 2. There are 2 codons for phenylalanine. Leucine, how many codons? 1, 2, 3, 4, 5, 6. All those codons for leucine. Like what I told you. One amino acid might have more than one codon. All those codons code for leucine. By using the genetic code table, I'll ask you to find out which amino acid is coded by CAU. How can I find it? Which amino acid is coded by CAU? I should start reading from the left column, this column. Where is C? This one. Then search at the middle column. I told you A. Third, I told you CAU. Find the U here. Here it is, CAU. It codes for histidine. So CAU. CAU codes for histidine. Another example. If I told you which amino acid is coded by GUA, start from the left column. Where is G? Here it is. G, U, here it is, U, A, this is A. So GUA for valine. In such a way, we know how to use this table to know the genetic codes and to know the amino acids that are corresponding to those codons.